For this demonstration, what we're doing is a titration. So we're using a solid sample, this is KHP, and we have a specific amount. So how much KHP is in here, we actually know how much it is. So we have a specific number of grams of KHP, and to that amount of KHP, we're adding 40 milliliters of distilled water. So this is just the sample preparation for the titration. So I'm doing this first because all of the KHP needs to be dissolved in the water before we start the titration. So while we wait for that, I will go over some other things. So we're using a burette to do our titration, and the burette was cleaned before adding the sodium hydroxide solution. So we're titrating our sample of KHP that we know how much it is with a solution of sodium hydroxide that we don't know the concentration. So we're actually using the volume of sodium hydroxide that is required to titrate our sample to do the calculations that we need to finally get the concentration of that sodium hydroxide solution. So once I have my KHP sample where the solid is completely dissolved in the water that I added, I'm going to add some drops of the indicator. So I will add 5 drops of this indicator, which is phenolphthalein, the one that we're using. Now, the KHP that we have here, it's an acidic solution. So it's acidic. So the indicator that we're using when it's in the presence of an acid has no color. Okay? So even after adding the drops of phenolphthalein here, which is just 3, it's not 5, between 2 and 3 drops in here, you won't get to see anything happening in here. The color will remain as clear. One, two, three. For to mix. And now the sample is ready for the titration. So I have my flask, the burette with the sodium hydroxide, and now I'm going to start the titration. So to start the titration, I have my flask on top of a paper towel, and this is just for you to be able to see the color change very easier. Now another thing is that the tip of the burette should be inside of the flask, okay? Just to avoid for some of the NOH to go outside of the flask when it's coming out of the burette. So what I'm going to do is that I'm going to add 1 milliliter of the sodium hydroxide to my sample at once. You will get to see what starts happening here. So the initial volume is at 0, and I'm going to open the burette until the volume goes down to 1. So you get to see the pink color in your sample. Okay? So I'm going to swirl and it will go away. So what's happening here is that your original sample, the KHP in the water, right? It's an acidic solution. So when you add the indicator, phenolphthalein, the 3 drops in there, it still looks clear because your solution is acidic, and phenolphthalein has a clear color in acidic solutions or in neutral solutions too. But phenolphthalein, it's pink when it's in a basic solution. Since what we're adding to the flask is sodium hydroxide, which is a strong base, you get to see the pink color forming in there. Once I swirl, the color goes away because in your solution you still have more acid than base, right? We have a specific amount of KHP in there. So at this point, with just 1 milliliter of sodium hydroxide, we still have more of the KHP than the sodium hydroxide. So the solution is still acidic. So that's why the pink color that you get to see, it goes away. When we're getting close to the equivalence point, where the moles of the KHP are equal to the moles of sodium hydroxide, when we get close to that point, the pink color will take longer and longer to go away because now your solution is very close to become a basic solution. So we're aiming to get a very light pink color in our sample because the lighter it is, the closer we are to that end point or equivalence point of the solution. So when the sodium hydroxide is added here to your sample, right? The reaction between the KHP and the sodium hydroxide is happening. So the KHP, which is the acid, right, it's reacting with the sodium hydroxide. So the moles of KHP are actually being converted to a product in this case, okay, for this reaction. So I'm going to open my burette here to let go the sodium hydroxide inside the flask, drop by drop. So very carefully, we don't want to add too much at a time. That it's too quick, that's better. So you can let this solution go in the flask, right, at a very slow flow, drop by drop, and you get to see the pink color, but look, when I swirl, it goes away. Now, the longer it takes for that pink color to go away, the closer you are to the equivalence point of the titration, which is what we want to stop the titration. So once we reach the equivalence point, the pink color should remain in the sample, but it should be a light pink color. We're getting very close to the equivalence point. You can see that it's taking longer and longer for that pink color to go away. Getting very close, so I'm adding the sodium hydroxide very slowly now. The color still goes away. So I have one drop here on the tip of the burette. I'm forcing that one to go down and mixing it. One drop. Let's check what happens with that one. Still clear. So we have to keep adding sodium hydroxide. Just making sure that there's no sodium hydroxide on the walls of my flask. All the volume for sodium hydroxide that we're adding should go in here. So there's a drop of sodium hydroxide right there. The pink color is still going away. There, done. So now at this point, we have added enough sodium hydroxide for your solution to turn pink. It's a very light pink color. The lighter the color, the better for your actual experiment. If the color is too, if the reaction looks too pink, right, or a dark pink, I will show you how it will look. It means that you have an excess of sodium hydroxide. Remember, in the presence of sodium hydroxide, phenolphthalein, it's pink. So if you have too much of the base, then your reaction is too basic and the color will be very dark pink. So I'm going to add an additional drop and you will get to see what happened to the light pink color. Now it's not light anymore because at this point we have too much of the sodium hydroxide. So the correct volume for sodium hydroxide that you're using in here should be the one that is giving you that very light pink color when you reach that equivalence point in your titration. So whenever you get that very light pink color, what you have to do is to record how much of the sodium hydroxide you use to reach the equivalence point in your titration.